Welcome to episode 33 of No BSTS. And if this is season 1 of this show, then this is the finale episode. But in this one, we are going to do a Q&A. We're going to go and take your questions, the ones I haven't answered, and answer them right now. So let's jump right into it. So the first one is representative of a whole bunch of questions that I've gotten over time when it comes to types versus interfaces. So let's go for it. And I love how this is phrased. I may have missed this, but does anyone have an easy explanation of the whole type versus interfaces thing? I tried the TS handbook, but I don't fully understand their explanation of it. I just love how you put that because it's just how I would have said it. The whole type versus interfaces thing. It's great. Okay, so let's jump right into it. Here's actually the Typescript handbook that you're referencing. And yeah, it doesn't give really any recommendations as to which one to use here. So I've included it and a couple other articles as well that should give us a little bit more detail that we can take a look at. I've found this one on LogReca is actually quite nice. And this one's from ultimatecourses.com. And they've got some good stuff in here, in particular, this rule down here. So for cases such as creating new types through things like primitives, union types, or tuple types, I prefer to use type. That's probably because that's the actually only way to do that. And then for anything else, I use interface. And actually, that seems like you're defaulting to interface, but I think actually we do a lot of both of these things. Now, the thing I find that's really driving all this confusion is that when you think about like a Venn diagram, right? So you've got everything that interfaces can do and everything that types can do. There's a ton of overlap between those things. Like you can really, all of this stuff in here is the stuff that we do all the time. And there's actually very little sort of over here in like the space of the things where they don't overlap. And so that's what's kind of driving this is that huge Venn diagram overlap of those two things. So let me bring up the TS Playground and we can talk about a few of the things that you can do with one and without the other. Let's start off with types. So for example, let's say we have a type of person and they're going to have a first name like that. And then you want to go later on in the code and essentially reopen person and add on last name. Well, you can't do that in a type. And this is actually something we haven't covered before, but you can do this in an interface. You can actually reopen interface and actually extend it like this. So this is something you can't do in a type. And if I were to go and define a person, then I would get in there the first and last names and be able to do all that fun stuff. Okay. So what can you do in a type that you can't do in an interface? Well, the basics. So in this case, like let's say a person name is going to be either a string or a number. We can name somebody with a number, right? That's the kind of thing that you can do in a type that you can't do in an interface. Going back to the suggestion over here, basically they're saying really anytime you're defining data, that's when you're going to be using an interface, the structure of data. But pretty much all the other stuff, like creating these union types, tuples is a good example, defining functions, then you're going to end up using a type, and that's fine. That's a good rule of thumb, and that's what I'm living by right now. There actually is a way to define an interface for a function, but it was so clunky that I decided not to actually cover it in the course, and that's this right here. I just don't like this syntax at all. And so this is defining this ingredients function as a type, essentially. This is the type version of that, and I think this one just doesn't read as well. If you ever need to manage this as a type, you're going to end up having to do it this way, but that's fine. All right, so there you go. A couple minutes on the whole interfaces versus types thing, which comes up an awful lot. Hopefully I addressed it for you. Okay, question number 2. This one's from Dedicated Managers, who's also a dedicated viewer, and I appreciate that. You use TypeScript getters and setters in this video. Have you discussed them, and how are they different from properties or functions? So I did not cover that. And the reason was that I was depending on that folks knew the basics of JavaScript coming into the course, and they're basically just looking for TypeScript to go on top of it. But while we're here, might as well talk about it. So a getter and a setter, and I love these. or something like this. So we have a class of person like that. And we might have a constructor that's got a public, first name like that. And then we can make a getter, which would have like full name. And maybe that adds on, adds first to last like this. Return this dot first and this dot last. And we're implicitly picking up the return of the string here, but if you want to, you can specify that as well. But as you can see over here, it actually translates directly into JavaScript. So in this playground interface, we've got our TypeScript over here, we've got our JavaScript over there. And so this is something that has been built in since the initial version of JavaScript that had classes. And what this allows you to do is, if I make a new person, like that, then I can do p.fullname, and it looks like a property. I don't have to do p.fullname as a function like that. It just appears like a property, which is really handy when you're building an interface. It's really nice. You can also kind of wrap stuff. So let's say I want to go and have, like, for example, a private, which is a job. So I'm going to have private job, which is a string over here. And I'm going to default that. And in here, I'm going to have a setter. So set job, and it's going to be a new job like that. And in this case, we can go and check some permissions, right? Do we have the permission to go and set that? And if so, then this job equals job. But the nice thing is about this, from the consumer standpoint, all we need to do is just say job equals foo, and it's going to do the right thing. It's going to call that setter. So there's a bunch of different times that I use stuff like this. If I want to go and make a read-only field, for example, I could go and say get job in this case. And that would return this job. But never set it, right? And so that's read-only. But that's runtime read-only, which is great. Also, when I'm debugging stuff, if I want to just be able to say, hey, I'm getting somebody out there is calling and setting this field, I want to know who that is. So I turn the field into a setter type, and then I can actually break on it and see who's doing the setting. So really good stuff. Nice feature of both TypeScript and JavaScript. Okay, so question number 3. Great video as always, Jack. I have a question. When you constrain the values of roll the dice function, what happens to the call if the callee passes an argument which is a variable and it is not constrained to the value range of 1, 2, 3, 4? So let's make this real quick. So we have a function. It's called roll dice, and I remember it was the number of dice. So we wanted 1, 2, and it was 1, 2, 3, or 4 dice. I think in this case. And then we're going to return some number, whatever. That's fine. We don't have to worry about that. So let's see. Let A equals 5. Roll dice A. Okay, so what this is telling us is that the argument of type number, which is A in this case, so A is number, is not assignable to the parameter type of 1, 2, 3, 4. And what you need to do is coerce it, essentially. So you say as 1, 2, 3, 4, like that. And you could do it like this as well. Possible dice. And then set that and set that if you didn't want to actually have to repeat that multiple times. But yeah, you do basically have to tell TypeScript that, yes, it's a variable, but yes, it does actually qualify. And hopefully you put in some runtime check around that. It's not going to do that for you. If you take a look over here, right, I've gone over and over on how TypeScript is not going to help you at runtime. Well, this is the JavaScript that was generated by that code. And so you can see that there is no constraint on here. There's nothing that's basically doing a type check in here. TypeScript, and we're compiling without errors, which means that TypeScript thinks everything is cool, and it's because you've told it that you're going to go do that check. In this case, well, we're lying to it, so that's not good. Okay, what's our next question? Okay, Harris says, does TS generate a bigger app bundle than native JavaScript? I thought compiled code from TS to JS looks pretty bloated. Okay, cool. Well, actually, let's try something like that. Let's go over here and we will do a REST operation. So I'm going to say const a equals, first jack, whatever, last h, and then we're going to say const b equals, and then dot, dot, dot a, right? Like that. So that's not too bloated, right? I mean, we're doing some pretty basic stuff here. We're doing object.assign. We're giving it a basic object, and then we're adding on all this stuff from A, which is kind of the way that you'd write it. And that's basically what you're going to get out of TypeScript. But it really depends on the target. So let's go over here, and we can set target to, say, ES3. It's crazy old. So look at what this is doing. It's actually doing like assign. It's creating an assign because there's none there. This is pretty intense stuff. So it really depends on what this target is. And you need to set that target so that it's right for your project. If you're targeting legacy browsers or targeting legacy node versions, then you're going to want to set this back to an older target. But if you are targeting modern browsers in a modern environment, then do something like ES Next. And you'll find that the code is effectively just the TypeScript code minus the types. So not a lot of bloating. And this is exactly what you get from potentially other transpiled languages. Actually, maybe even a less, because again, all we're doing is essentially just kind of stripping off the types and giving you your JavaScript. All right, so next question, and this is more of a comment, but I think it's great and definitely worth looking at. So I think default exports in general should be avoided. There are even TSLint, ESLint rules that check that, no default exports. Some, for good reasons, are listed here, and it gives a link, which I'll put to in the description. And I think Jacob is totally right on this, and I flipped myself on this. So the idea is that instead of doing, like, let's say, a class person, and then you export default as person, and in that case, you do import person from, let's say it's in .person, something like that. As an alternative, you would do export class person. And in this case, you'd import it like so. And the reason this is better, and there's a bunch of reasons for this, is that you don't remap on the client side. You can actually change the name if you want to, which is something you can't do with default exports. But if you want to track how a component or a function is used through the whole code base, having named exports is great, and having default exports is terrible. So I heartily encourage you to read that article. Okay, next question from Peter. Honestly, what do you think is better when creating hooks, which return multiple, sometimes many values, either using a tuple or an object? I always use a typed object in return because then it doesn't matter what order I write them in, and I get good auto-completion with VS Code. Awesome. Is there any advantage to using a tuple over an object? No. I totally agree with you, Peter. This is absolutely. So what Peter's talking about is in React, we have these custom hooks. So let's say that we've got a function, get user, right? And he is doing something like this, where we return, user is Jack and ID is foo and all of that. And the way that you would consume that is you'd say const, ID equals get user, something like that. And the value there, to me, is that you can actually kind of pick and choose what you want out of this hook, right? Maybe you don't want user. Maybe you want something else. Maybe you want, this callback or that callback or whatever. And I do that a lot. I'll go and build a single hook. And in some places, I'll use some parts of it. In other places, I'll use other parts of it. Now, the tuple variant would be something along the lines of, kind of string like this, and then do return, I guess, Jack and then ID or something. I don't know. What does that mean? So like that, name, I guess, an ID. And if you don't want the name, then you do something along the lines of underscore to just kind of avoid it. It's just ugly. So no, when I create my own custom hooks, I never use tuples unless it's a direct replacement for useState. So useState is the one time that I think that tuples are really good in that scenario, but I don't do them anywhere else unless I am replacing useState. So useState, let's just say that you have a name and a set name, and that's useState on a string, something like that. You actually don't have to do string in this case, that's inferred. I think this is really good. Why is this a good tuple pattern? Well, you're going to have a lot of these. You're going to have, name and age or, whatever, right? And if useState returned an object, then you do a lot of remapping. So let's say that useState in turn returned like a state and a set state as objects. So state and set state is the result of useState. This is not the case, but were it the case, right, you'd see a lot of this. Name, and then set name, right? Because you're going to have a ton of different useStates, right? You're going to have a ton of this remapping. So I think tuples really, really work well in this one case, but in general, not a great pattern. And for me, when I think about it, a tuple of 2 items is fine-ish. A tuple of 3 items is maybe okay, but a tuple of 4 items or more, no, not okay. Not something I want to see, not something I want to maintain. All right, next one's up from Payush. Great video, thank you. I was wondering if there are any ways to share types between backend and front end without importing extra compiled code from the back end into the front end, just only the types. Would be great to learn about it. Okay, so this kind of harkens back to episode 1, when I talk about the biggest misconception when it came to TypeScript, and that's that the types make it into the compiled code. So let's go and make a type here. In fact, we'll make an interface in this case called person. It's going to have a first, a string, and last, a string. But keep a keen eye on what's happening over in the JS over here. Nothing is coming out, right? Let's check that out. So let's say, print person. And that takes a person, which is defined as a person. And then we'll do a console log, whatever. It doesn't really matter at this point. So what you can see is the only thing that's making it into the JS code from the TS code, right, is the actual implementation of stuff. That's the only thing that's making it over here, right? All of this stuff, it never makes it over, right? It's just compile time. It's only there for compile time reasons. So when you talk about whether the back end is going to add code bloat to the front end with all these types, it's absolutely not. All you're going to do is just synchronize the types between the back end and the front end at compile time only, which is a really important distinguishing factor there. So my recommendation to you, Payush, is to go and create an NPM module that has your shared types in it, and then share it between your backend and your front end, particularly for the purpose of getting that alignment right? You don't want to go and have one copy of user definition for the backend and one for the front end. If you want them to be exactly aligned, you want to reuse both. And to get that happening, then use a shared NPM module. And if you want to see how to do that very easily, go and check episode 32, where we talked about NX and monorepos, and that'll show you how to go and reuse modules between the back end and the front end. Scott asks, great series so far. I'm learning a ton. Awesome. Question though, what utility would you use if I wanted a specific optional property to be required without changing any other properties? Okay, let's give that a try, Scott. So I'm going to go and create a person, and they're going to have an ID that is required. They're going to have a name, which is optional, and I don't know, whatever, an age, which is also optional. Okay, so I want to have a person with required age, and we will make it person, and then pick out of it, pick from person, age, which I don't think is going to make any difference right now, but then I can add on top of it required. So now let's see, has that actually worked? Hold on, let's go over and try and do this. So I'm going to go and do, function print person, and say, P is a person with required age, and we'll see. Okay, so what do I need here? I need ID. That's required. Is that good enough? I need age, 22. Okay, yep, perfect. So there you go. Decent combination. So we're going to take our initial person and then basically just override it so that we're going to pick off that one particular age and then make it required on top of that. And so you see, and probably if I did Command K, Command I in VS Code, we'd see that ID is required, age is required, but now no longer is name required. It's not actually showing our completed thing there, but it works. So that's great. So that's how you pick off one field and make it required. Okay, last question. Srikar asks, do we miss out on anything if I don't explicitly set the type and just proceed with the default TS inferences? Fantastic question. So let's start off with number one and talk about all the things you might lose if you don't do some adding on typing. I mean, an example is something like this, add numbers, and we're gonna have A and B, and I'll say, A plus B, that's fine. And what he's pointing out is you really don't have to, at this point, say number. Right, that is inferred. And TypeScript is fantastic at inferring stuff. So my suggestion is, no, you don't have to do that. You really should make sure that every single parameter or argument to a function, that's typed. But the return type, I think you can get away without that in most cases. You can go and set tsconfig so that it enforces that you must have a return type. And I think in some cases it might be good. For example, if I have a really complex function that should resolve to a string, it's really nice to know that all of the return points return a string. If you leave this out, so if moon is in shadow, right, we're just going to return, and we'll make moon is in shadow a Boolean, right? If I didn't have the string here, I wouldn't know that this is there, because this is what's really happening is this is going to be an undefined, right? And so that would allow that. But if I really want to make sure that this function only ever returned a string, then having that in there actually helps me make sure that my code is working properly. Another thing around this, I don't ever do like typing of this sort of stuff. I know early on in the series I did, right, something like that, but that was really just to kind of reinforce that there are types, but that's not actually practically how I would code on a daily basis. I generally code just like this because this is implicitly a string, and since it's a const, it's never not going to be a string, and it's never not going to be that value. Similar sort of thing with a number, 22, or a bool, true. One thing for sure, though, and this is just a personal thing, I always use const whenever I possibly can. I find I try to not use let ever if I can get away with it. So, and I encourage you to do the same, because that actually is helpful in writing really consistent, clean code that's very strongly checked. We've got const, so you might as well use it. And I only ever use const, and then very, very rarely will I use let. Okay, well, I hope I've answered your questions. If you have more questions, put them in the comments, please. It was really fun doing this, and I wouldn't mind doing a Q&A too, if y'all have more questions. And I'll be honest, YouTube really highly rates videos that have a lot of comments on them. So you can do me a solid. If you like the course, if you like the series, just add some comments. They're free. All right, well, in the meantime, if you like the video, hit that like button. If you really like the video, hit the subscribe button and ring that bell, and you'll be notified the next time a new No BS TS video arrives.